of the Army Air Force's training program is gunnery accuracy. During the final stages of flight training, pilots and gunners are sent on gunnery missions. Only by continual practice on actual targets can they hope to perfect their aerial marksmanship. Whether ammunition is live or simulated, the quick eye of this gun sight aiming point camera notes the aim for each shot and records permanently and pictorially exactly what the gunner saw at the time he pressed the trigger. When the mission is completed, the armorer removes the film magazine. From the information on the flight report, the armorer then fills in the scoring data form. First, the magazine identification number, then wind direction and velocity for ground targets, speed of the airplane at time of firing, and in the case of aerial targets, the firing altitude. Then the number of exposures per second at which the camera was running, and the type and size of ammunition used or simulated. This form and the film magazine are turned in to the chief armorer. He forwards the magazine for all missions to the processing department, where the film is punch marked for identification. And then developed prior to scoring. Let's go to a classroom to study the important procedure of scoring.
Men, this reel of processed film contains the records of many missions. And, if properly scored, may help to save the lives of as many pilots in some future battle. The film is wound on 100-foot reels for scoring and filing. All process splices are removed because these will damage the scoring projector. Also cut out all unnecessary film lengths. Attach a short strip of blank leader in front of each length of film, joining all film ends with the usual film splices. Identify each mission from the punch marks. Now pick out the corresponding scoring data form. On the leader, write the name of the pilot, the date, and the number of the film magazine. India ink makes a permanent record on the emulsion side of the film. Repeat this process for each mission until all the films have been identified. The film is now ready for analysis to determine the hits or misses made by the pilot or gunner. This procedure is known as scoring. Scoring is accurate for three reasons. First, because each picture is a photograph of the gun sight image superimposed on the target. Second, because each picture shows the relation of the gun sight to the point of impact. And third, because each round is represented by a picture taken approximately when the gun was fired. The actual scoring is done on the film scoring viewer. This viewer uses a standard 16mm motion picture projector, which is threaded in the usual manner. The pictures are shown through the translucent screen. The operation controls are grouped handily around the screen. To change from continuous projection, this small lever operates a clutch for showing single frames. This simple crank control moves the film forward or backward, frame by frame. This series of calibrations around the edges of the screen is the standard base of measurement. The film scoring viewer is equipped with two movable index lines. Now, one control moves the horizontal line up or down across the full face of the screen, while the other control moves the vertical line across, either from left to right or right to left. Every scorer is provided with a supply of the 6 basic scoring forms. Form G is used for ground targets. Form T is used for tow targets. And the forms A are used when the target is another airplane. Select the one which most nearly corresponds to the type and attitude of the target. Certain units may find it advisable to devise additional forms as required. All the necessary technical aids are supplied. One of these is the measuring stick. Now, this is used to measure the span of the target in inches or in mil units. The movable index lines also may be used in measuring by referring to the markings around the edges of the screen. Also furnished by ordnance are trajectory data tables for the different types and sizes of ammunition which may be fired or simulated. These tables are used to determine the exact flight time and course of each projectile. Other tables show span calibrations. If the actual span of the target is known, these tables convert screen measurements to exact range distances. Ground targets and tow targets are standard in size. Their exact dimensions are given to every scorer. Airplane measurements, of course, will vary. The latest issue field manual on the identification of United States military aircraft provides the actual span measurements. And now, to go through the steps of scoring a gunnery mission. First, pick the opening frame of a single burst. This represents the first shot fired. Choose the proper scoring form. In this case, it's A1. Now, pick out the scoring data form which corresponds to the mission now ready to be scored. Transfer the details to the scoring form. Measure the span of the target with a measuring stick. The target airplane measures 2 inches. Note this measurement. In this case, the target airplane is an AT-6. The field manual gives its dimensions. Measure the profile view in the manual most nearly in the attitude of the target airplane. According to the scale, it measures 28 feet. Now, enter this figure as the actual span of the airplane. On the span calibration table, find the column of target size nearest the actual measured span of the target airplane. In this case, the 28-foot span column. Pick the figure in this column nearest the screen measurement, 2 inches, and we see the range is a bit less than 200 yards. Enter the range on the scoring form. Now that the range is known, the proper trajectory data table will provide a final item of information. For example, the exact amount of time in seconds the projectile takes to travel any distance. The altitude of the attacking airplane was 3,000 feet. It was firing .30 caliber ammunition. It was traveling at a speed of 150 miles per hour. The time of flight for a .30 caliber bullet for 200 yards is 223 thousandths of a second. It's now necessary to find the location of the target airplane at the end of 223 thousandths of a second, the time of flight of the projectile. Well, we do that by moving the vertical crosshair until it rests on the nose of the target airplane. It's 69 units from the middle 0 point. Now, bring the next frame into position. Move the index line until it again rests on the nose or leading edge of the target airplane. Note the position of the line at this time, 57 units. The difference between these readings gives the total forward movement of the target between the time of taking these two pictures. This movement was 12 units. The camera was set to run at 32 pictures per second, or 1 picture each 32nd of a second. Well, multiply the 12 units of screen travel by 32 to determine the total screen travel in a full second. The total travel is 384 units. Multiply these 384 units by 223 thousandths of a second. That was the flight time previously determined for the projectile to travel 200 yards. The result, about 86 units, is the total target travel during the time of flight of the projectile. On the viewer, turn back to the first picture frame, the one being scored. Use the measuring stick to establish this target travel distance, measuring from the center dot. Move the vertical index line to this point. The bullet actually traveled somewhere along this line. This is the absolute lead from the gun to the point of impact at a 200-yard range. The correct lead is within the area which would be covered by the screen image of the target, placed both before and after the point of absolute lead. Measure the length of the target. The length of the target is 48 units. So you see, the correct lead can be either 48 units more than the absolute lead, or 48 units less. Here's how this works. According to the markings around the edge of the screen, the limits of correct lead can be established at these points along the line of flight. And remember, the projectile travels 200 yards to intercept the flight path. If the lead is less than 38 units, the projectile will pass harmlessly behind the target. But if the lead is more than 134 units, the projectile will pass in front of the target. If the lead is anywhere between these two limits, the bullet may intercept the target. And now to make the entries to cover these findings. Enter as correct lead 38 to 134 units. Actual lead 69 to 117 units. Move the horizontal index line until it's directly over the center dot. The vertical index line is at the absolute lead, 86 units, where it crosses the line of elevation. That's the point of impact. This cross is definitely on the target. This shot scores a hit. To complete the scoring form, circle the approximate location of this hit on the scoring form target profile and number the circle 1. And then under the column hits, place an X. This entry completes the scoring procedure for the first shot of the first burst of this mission. The other frames now are scored in the same way until all shots are scored as hits or misses.
This entire scoring procedure doesn't take wind into consideration. Isn't this necessary, sir?
Yes, it is, but only for ground targets. The error involved is too slight in the case of aerial targets. In the case of a gunnery mission on ground targets, the direction and velocity of the wind at the target must be entered properly. Space is provided on scoring form G for ground targets to note this information. This is the way to compensate for wind deflection. Subtract the velocity of a headwind from the speed of the airplane before making any computations. Add the velocity of a tailwind to the speed of the airplane before making any computations. Crosswinds will deflect the projectile at the rate of 1.466 feet per second for each mile per hour of wind velocity. Of course, these deviations are calculated only once for the entire mission.
What is the scoring procedure if the entire target isn't within the picture area, sir?
The scoring procedure is the same. An extremely fast-moving target may make a long lead necessary. All of the target may not be in the picture. Also, this may be the case at short ranges. In these cases, measure the portion of the target which does appear and use that as a basis for range determination. Particularly in scoring tow targets, the height measure is most accurate.
Is every frame scored, sir?
No, every frame is counted, but only the first frame of each burst goes through the complete scoring procedure. Each frame after that, within the burst, can be judged from the results on the first frame. Every step of the scoring procedure must be followed carefully in order to preserve the value of the film taken by gun sight aiming point cameras. Now let's quickly review the steps in the scoring procedure. The armorer must make the proper entries on the scoring data form. The film must be developed carefully to produce clear pictures. The film must be properly identified and spliced on the film editor. The scoring viewer must be kept in good working order. All technical data and forms must be readily available. All measurements must be made carefully and accurately. First, find the span of the target on the screen, then use the proper column of the span calibration table to determine the range. The trajectory data tables will give the time of flight for every projectile at any determined range. The change of position of the target between two picture frames is the basis for determining the travel of a moving target. This is the theory of scoring. The position of the target along its course can be calculated accurately to determine the point of theoretical impact. If the actual lead is within the limits of the correct lead along the sight line, a hit is scored. If the actual lead is not within the limits of the correct lead, or the airplane doesn't cross the path of the bullet, a miss is scored. No matter what type of target is used, or what position the target airplane was in during the attack, the scoring procedure is exactly the same as for the beam attack we just scored. Gun sight aiming point cameras in aircraft help to train pilots and gunners quickly. When the films are scored by conscientious operators, skilled in making each picture tell its complete story of gunnery accuracy, the results will mean a better pilot or gunner in the United States Air Forces.